A warm greetings from Dr. Muthuselvi. Let us discuss on the topic addressing modes, which is a very important topic in the course Computer Organization and Architecture. See, whenever we are writing a program, it may be a high level language program, or we can go for assembly language program. So here there is an example for the assembly language program where we have the instruction move LOC, R1 at R1, R2, R3. So whatever the program it may be, we need the data. So in the program, of course, we are going to use the data, and the data is residing in the memory. So and the data, actually it is organized in a particular way. So as a programmer, I can use the data structures, for example, lists and arrays. So here also you have the data. So how to get the data which is residing in the memory? That is the question, and that's where we have the topic addressing mode. Let us see the formal definition for the addressing mode. So it is the way for specifying the locations of instruction operands. Actually, it is a technique used to specify the address of the operand. So here in our program, whether it is high level language program or assembly language program, we are going to have variables and constants. Of course, we have the pointers and we may be using arrays. So for accessing all these data, we are going for addressing mode. So let us see the implementation of variables and constants, where in the program we have the variables and the constants. So we have to access them. So for accessing them, we have one addressing mode which is called as register mode. So here the operand is the contents of a processor register. The name of the register is given as the operand. So here one example, add R4, R2, R3, which is an instruction in the assembly language program. So this particular instruction adds the content of R2 register and the content of R3 register, and the result will be stored in R4 register. So in this instruction, all these are registers. So the source, it is R2 and R3, the destination R4, all these are registers. That's why we call this addressing mode as register mode. The second one, it is absolute mode. So here the operand is stored in the memory, and the address of this particular location, that is given explicitly in the instruction. Let us see one example. So load R2, num1. So here this instruction, it copies the data from the location, memory location NUM1 to the register R2. So here the address of the operand NUM1, that is given explicitly in the instruction, and we can say this particular instruction uses absolute mode. The next one is immediate mode. So sometime we are using some constants in our program. So here the operand, actually in some instructions we are giving the operand directly in the instruction itself. So here suppose I am using the constant. So here the addresses, it can be found in each and every computer program. So this constant representation in the assembly language, actually it uses the immediate addressing mode. Let us see the example. So add R4, R6, 200 immediate. So that can be actually written like this: add R4, R6, hash 200. So here hash 200, it is the symbol used to specify that this particular instruction uses the immediate addressing mode. So here the content 200 or the operand 200 is added with R6 content and the result will be stored in R4. So this is the example for the immediate mode. Now let us look at the term effective address. So effective address is the exact address where I can get the data, where the data is available. So here sometimes we are going to get the effective address from the instruction, and from that effective address we are going to access the data. So this effective address is related to this indirection and pointers. So here I am going to have the register indirect addressing mode. So here the effective address of the operand is the contents of a register which is specified in the instruction. See, let us take one example. So load R2, R5, that is, it is written within parentheses. So now the processor, it is looking for the content of the register R5. Then in R5 I have the data 500. So now 500 gives the address of the operand. So at location 500 the operand is available. So now the value from this location, that is 500, is taken for consideration. So now this is the register indirect addressing mode. Another addressing mode is index mode. So here, see, let us have the effective address that can be found out by adding a constant to the content of a register. So now let us see here one example. Load R3, 30, content of R9. So the content of the register R9 is added with the constant 30, the value 30, and that value actually it gives the address of the operand. So here load R3, 30, R9. So in R9 I have the value 1000. So the offset, that is 30, is added with 1000, and in the location 1030 I have the operand. So here we can say the index mode is used. So in an assembly language program, actually X is given either as an explicit number or it is given as a symbolic name representing a numerical value. So the X value, it is a signed integer. So even we can go for sign extension if required, and the offset is given as a constant which is given in the instruction. So let us take one example from real world. So let us take a list of test scores for students in a class. So now we have the data list of scores, and for each and every student they have the roll number. So the beginning location, it is now LIST, that is the symbolic name we are using. So a forward memory block, so it is going to have the data for one student. For each and every student a forward memory block is used to store the roll number as well as the test marks. So each record, so you are going to have the identification, that is the roll number, followed by the test scores of the each student. So now let us assume there are n students in the class, and of course n value, it is going to be stored in a location as in n. See, let us take this. So the address is capital N, where I have the data as n, that is the number of students, and next address it is LIST. So the student ID, for example the roll number of the first student. So list plus 4, at that location I have the mark 1 of the first student. In list plus 8 I have the mark 2 of the first student. In list plus 12 I have the mark 3 of the first student. Then from list plus 16, I have the data for the second student. So here I can say this particular index mode is used. So apart from that, we have auto-increment mode. So here the effective address is found out by the contents of the specified register in the instruction. So after accessing the operand, then the content of the register is automatically incremented so that the next item in the list will be found out. So one example, RI plus. So here RI, it may be any register, for example R6 plus. So here the increment is always 1 for byte sized operand. If the operand is of 16 bit, then 2 is incremented, sorry, R is incremented by 2, and if it is a 32 bit operand, then 4 or register is incremented by 4. Of course, we have the auto decrement mode also. Here it is RI minus, so the content of the register will be decremented. Again, it depends on the number of bits for the operand, as we have discussed in auto increment mode. So now let us summarize the addressing modes. It is register mode, where we have the registers as having the operands. Then we have the absolute mode. The address of the operand is given in the instruction explicitly. Immediate mode, the operand is given in the instruction explicitly. I have the register indirect addressing mode. The register contains the address of the operand, and from that address I have to find out the address of the operand. I have the index mode, so a constant will be added with the contents of the register. I have auto increment mode, where the register content will be incremented automatically. Similarly, I have this auto decrement mode, where the content of the particular register is decremented automatically. Let us identify the addressing mode, which we are given different instructions. The first one, let us take that, subtract R5, R1, R2. So the addressing mode is register mode. So why do we say it is register mode? Because all the operands are available in the registers, and the result is also going to be stored in the register. The second one, add R3, R2 hash 15. So we can say it is immediate mode, because here the one operand, the constant number 15 is given explicitly in the instruction. Come to the third one, load R3, num1. So the addressing mode is absolute mode. So here the instruction uses the absolute mode to access the value available in num1. Another instruction, load R5, R3. So here we can say indirect mode is used, because in register R3 I have the address for the operand. So from that address I have to fetch the data. So it uses the indirect mode. Then store R2, 40, R4. So here I can say it uses index mode. So here the index value 40, that will be added with the content in R4, so that the next item in the list will be found out. So in the RISC type architecture, we have the following addressing modes. Immediate, so here the assembler syntax is hash with value. So the addressing function operand will be equal to value. Then the next addressing mode is register, where I am going to use any register, that is RI. So here the effective address, it is equal to RI. Then the next one, absolute. So here LOC, that is the assembler syntax. Then the effective address will be equal to LOC. Register indirect, that is written within parenthesis RI. So here the effective address will be the content of the register. Index mode, X of RI. So here effective address will be the addition of the content of Ri and X, that is the constant value given in the instruction. Then base with index Ri Rj. So here the effective address will be found out by adding the content of Ri and the content of Rj. So thank you.